Hello everyone. So in this video, what we're going to be talking about is actually two things that seem very unrelated, and they seem almost like they're unrelated to what we've been talking about up to this point, but actually putting them into linear equations makes perfect sense, and I think that you'll see why. So we're going to start with something called literal equations. So literal equations are equations where we have multiple variables, and we work with literal equations when we're trying to solve for one of those variables. So in some cases, you might have multiple unknowns, but you know what some of those things are. So let's just do some examples so that you see what we're talking about. And I want you to note that all of these things you already know how to do, okay? So there's nothing really new here. So a literal equation is an equation with more than one variable. Okay, let's take an example. Anybody who is sort of remembers geometry, okay, might remember that the area of the circumference of a circle is C is equal to 2 pi r. Okay, so you can see here, this is an example of a literal equation. We have more than one variable here. These are our variables, so we have two of them. Remember, pi is an actual number, right? Pi is 3.14159, so forth. Okay, so these are our variables. And right now, this is solved for C. So this is solved for the circumference. Okay, we say that because C is what's all by itself on one side of the equal sign, right? Okay, but let's say, so this works great, okay? If you want to find the circumference of a circle, you can do that as long as you know the radius. So let's just put this in here, just in case for those of you who might not have done geometry in a really long time. This is the radius of the circle. This is the circumference of the circle. And when you used to do something like this in geometry, you would be given the radius, or the radius would be something that you could find, and then you would figure out what the circumference is based on that. Now, the thing about these literal equations is that sometimes you're given a different unknown. So instead of being given the radius, what if you were given the circumference? Okay, so let's take this C equals 2 pi r and let's solve it for the radius instead. So now we want the radius all by itself on one side of the equation. So if we do that, remember, the 2 and the pi are being multiplied by r. So to get rid of them, we're going to divide by 2 pi. Okay, and the 2 pi cancels. We're left with just r, which is what we want. And what we get here, let's actually put this in black as our equation. We get that r is equal to C over 2 pi. So it's the same equation, it's just solved for a different unknown. Okay, this one is solved for the radius. And the reason that you do this is based on what information you're given. So if you were given the circumference and you're trying to find the radius, you're using the same equation, but you're solving it for r. Okay, let's take another example, something that maybe you're familiar with. Okay, let's take distance equals rate times time. Okay, and again, this works really well if you know the rate and you know the time. But what if you are trying to figure out, so this, let's say if we're trying to figure out how far we've traveled, think of yourself in a car. And I tell you that you're going 60 miles per hour and you've been traveling for 6 hours. How far have you went, right? Then we would solve it for this because I've given you rate and time and now you're trying to find distance, okay? But what if I give you something else? What if I say that you're going 60 miles per hour, you've went 360 miles, how long have you been traveling? Okay, so now we want to take this equation and we want to solve it for t instead of for d. How do we do that? We just get rid of the r on this side. And again, we multiply by the t. So now what we get is that t is equal to d over r. Now we could have solved for r instead, right? We could have divided everything by t, and then we would have had r is equal to d over t. And all of this has to do with, okay, what are we looking for? Are we looking for the distance and we're given the rate and the time? Are we looking for the time and we're given the distance and the rate? Or are we looking for the rate and we're given the distance and the time? Okay, so these are all the same equation solved for a different unknown. So you're solving for the unknown that you want to find, and most of the time, everything else is given to you, okay? If it's not given to you, then you're trying to say, okay, well, I want to figure out what the rate is given lots of different times. So if I told you that I traveled 60 miles and I want to know what my rate is if I traveled for 10 hours, what my rate is if I traveled for 3 hours, for 2 hours. So in that case, it might be r equals 60 over t. Okay, so you're solving for the unknown you want to find. And this is something that you would have to be told. Okay, or, obviously if you're doing your own research or your own investigation, then you already know that what you want to find. Okay, so let's take a bunch of different literal equations and let's solve them for different variables. So we're just going to do a bunch of examples here so that we get used to it. Keep in mind you've done this already. You did it when we talked about the equations for linear functions, and we talked about converting either to slope-intercept form or standard form, right? If it were in slope-intercept form, then what we did is we solved for y. So it was a literal equation because it had an x and a y, and we solved for y. Now, on the other hand, when we converted to standard form, we didn't solve for a specific unknown, but we did solve for the constant. So we still were solving for something, okay? So I'm just going to go through a few examples, and we're just going to solve for different variables, okay? So in these, I'm going to give you the equation, and we're going to say what we're solving for. So 2 times PR plus 8R is equal to 3x. And we're going to solve this one for P. Okay. This means that we need p all by itself. So we need to solve this equation. So think about it as if this r, these r's over here were numbers. How would you deal with it? So the idea is you want to get the term that has the p in it by itself. So we're going to get rid of this 8r. So we're going to subtract 8r from both sides. So notice this 8r is going away, and we're getting closer to getting that p by itself. So this gives us 2pr is equal to 3x minus 8r. And you could have written negative 8r plus 3x. That would have been fine. There's no official order here. Okay. Now we still need to get the p by itself. Well, p is being multiplied by 2 and r. So in order to get rid of it, we can do this all at the same time. We can just divide by 2r. So the r's go away and the 2's go away. And what we're left with is p equals 3x minus 8r over 2r. And you can stop there. This is it. So one thing that I want to warn you about is you want to make sure that you can't reduce your fraction. Right? Can we pull out any common factors? So this is a reminder of the very first video on order of operations. Here, we can't reduce. So this 8r is attached to this 3x. If you remember, there are invisible parentheses. So what you're looking for is a factor, something that every term has in common. There's nothing that every term has in common. The 8 and the 8r and the 2r have an r in common. But that's not enough. The 3x also has to have an r in it, okay? Same thing with the 2. 2 and 8 both have a 2 in common, but that's not good enough, okay? Every single term has to have the same thing in common so that you can cancel it out from every single term, okay? Remember we said it's like we are factoring it out of the numerator and then canceling? Okay, so we can't factor this r out of the numerator because 3x doesn't have an r in it. Okay, so what you're looking for is something that every term has in common. And in this case, there's nothing. So this would be our final answer here. Okay. You do not need to separate this fraction. You would not be incorrect if you did. In other words, it would be okay if you wrote 3x over 2r minus 4. I would give you full credit for that. If you have no idea what I'm talking about, don't worry about it. But essentially what we're doing is we're saying we can break this fraction up into two fractions. The first fraction is 3x minus 2r. And then minus 8r over 2r. And 8r over 2r simplifies to 4. So you can simplify it that way. That is not necessary though. Okay, this is enough. Okay, let's do another one. So, second example. Let's do ax squared plus 3bc is equal to 4p. And this time we're going to solve for b. Okay. So here's the b. We need to get this by itself. So in order to get it by itself, the first thing that we have to do is get rid of this ax squared. So we're going to subtract ax squared from both sides because it's being added to the 3bc. right? So to get rid of something that's being added, we do the opposite. We subtract it. I crossed that out. I didn't mean to do that. I meant to cross it out on that side. So this leaves us with 3bc is equal to 4p minus ax squared. And then once again, the b is being multiplied by both a 3 and a c. So we're going to divide by those. That's going to get rid of the c and the 3. Which leaves us with b is equal to 4p minus ax squared over 3c. And we're done here. This is it, okay? There's nothing that every single term has in common. This is the only term with a p. This is the only term that has a multiple of 4. This is the only term with an a. This is the only one with an x. This is the only one at the bottom. This is the only one with a c. And it's the only one with a 3. There's nothing that all of them have in common. So this is our final answer. Okay, we're going to do 3 more, just so that you get really comfortable with it. Let's do x over 7 plus y over 9 is equal to 1. And this one, we're going to solve for x. Okay, so notice every time I tell you what is being solved for. Okay, so this is very similar. Okay, we need to get the x by itself. So the first thing to get rid of is this y over 9. Worry about that first. Okay, so how do we get rid of it? Well, it's being added. So we subtract. So we're just going to subtract y over 9 from both sides. Don't get scared by the fractions. They don't mean anything here. You can always get rid of fractions, but for this, it's not necessary because you're not coming up with a final answer or anything. You're just solving for a variable, okay? So it might be helpful. Eventually, you would wind up with the fractions again anyway, but it's totally up to you. Do whatever you're comfortable with. Okay. Again, here you're not adding or subtracting a fraction from a fraction, so that's why it's not really a big deal. Okay. Okay, so now we still have this x over 7. So don't be fooled here. This is not complicated, okay? Don't make yourself crazy. We're dividing x by 7, so how do we undo that? We multiply by 7. So that just means that we're multiplying everything by 7. So this side gets multiplied by 7. And this whole side gets multiplied by 7. So that means that the 7 is going to be distributed. Okay? And the 7 on the left cancels. It goes away. So what's our answer here? We get that x is equal to 7 minus 7y over 9. And once again, there's nothing that can be canceled here. There is no reason at all, okay, to turn this into a fraction and add or subtract these. There's no point to doing that. You're not simplifying. You simply say, okay, if I had a y, I could plug in the y and solve for x. So that's enough here. So this is our final answer. Okay, so you can see that these aren't so bad. It just takes some practice. So I'm going to give you another one. We'll do 2 more. These are a little bit different because they have a lot more variables in them. I mean, probably not so many more than like example 2. But they're a little bit different. So what I'd like you to do is for these, I would recommend that you pause the video and you try it on your own. You see how it goes. And if it goes well, then you know that you're in really good shape. Okay? So example 4. 3r squared k l minus 6 r cubed is equal to 9 . 9 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . L squared Q. Okay. And this one we're going to solve for K. So it seems like there's so much more here, but actually there isn't, because it's still this two-step process, right? In all of these, we've essentially added or subtracted something from both sides, and then multiplied or divided something on both sides. So here is pretty much the same, okay? We're adding or subtracting something, and then we're multiplying or dividing because we need to isolate the K. So again, good time to pause the video, try it on your own, but this is how we're going to do it. The K is in this first term here, so we're going to bring this second term, this minus 6r cubed, over to the other side. How do we do that? Well, it's being subtracted, so we're going to add it to both sides. Remember, it's got to cancel out, right? It's got to be that you're crossing it out from one side. If you can't do that, then you're not using the correct operation. Okay. So what does this give us? This gives us 3r squared KL. That's what we're left with on the left. And then 9L squared Q plus 6R cubed. And actually, I know that this is a last minute thing, but I'm going to add in an R over here. I'm doing that for a reason. You will see what the reason is in a little bit. Okay, so we added in an R. Okay, so the next thing that we have to do is, again, we have to get the K by itself. So in order to get that K by itself, we have to get rid of the 3R squared L. All of them are being multiplied. So we can do this in one step. We could divide by all three of those things. So we're dividing everything by 3r squared L. So that we're left with only K on the left, okay? And this is what we're left with. K is equal to 9L squared QR plus 6R cubed over 3R squared L. Okay, so remember, before you say, oh, we're done, we have to look for a common factor, something that every term has in common. And there are actually a couple of things, okay? So first, you'll see the coefficients. This has a 9, this has a 6, and this has a 3. That means all of them are divisible by 3. So we're going to divide everything by 3. And I'll put this in blue, just so that you don't confuse it with anything else. This is just canceling. 3 goes into 3 once, 3 goes into 9 3 times, and 3 goes into 6 twice. Okay, and you don't have to rewrite this. I am going to rewrite it just so that you don't get confused. And if you're somebody who gets confused when there are a lot of lines in there, then I recommend that you do this too. Okay, so now we look at this, and again, before you box any answer at all, you always want to ask yourself first, is there anything that's common to everything? And there still is. If you notice, every term has an R in it, okay? This has an R, this has an R cubed, this has an R squared. So we can take out one R. We can't take out more than one R because this first term in the numerator only has one of them. So we can take out one R. So we're going to do that from every one of these. This one, that means that the R just goes away completely because we took it out. For the R cubed, it means that it becomes an R squared. Instead of having 3 R's, we only have 2. And down at the bottom, instead of having 2 R's, we only have 1. So now, our final answer is 3L squared Q plus 2r squared over RL. And if we look at this, and once again we say, is there anything that every term has in common? There isn't, okay? Two of them have an L, but the third one doesn't. Two of them have an R, but the third one doesn't. Only one of them has a Q. And 3 and 2 have no common factors, okay? So this is our final answer. So the thing about this is most people forget to reduce. Most people forget to simplify the fraction. Do not forget to simplify the fraction. So I'm going to write that again here. Some people don't like the word of reduce because they feel like it means that you're making your answer smaller. You're not making your answer smaller. Think of it as reducing the numbers. You're making your numbers smaller, but not your answer, right? These two fractions are exactly the same. We've just taken out some of the repetition here, okay? So this is our final answer here. And you'll see that I added the R so that you could see that what happens when we can cancel an R out, okay? Let's take one more. One last one. Let's say that we have 12p q to the 5th minus 4rq cubed is equal to, and we'll add in just a little bit to this just so that you're really testing your understanding. We'll say that this is equal to 8 r squared q to the 4th plus 4 L Q squared, and we'll leave it at that, okay? So this one, we're going to solve for P. Okay? Okay, pause it, do it on your own, and then start it up again and see if you got the correct answer. Okay. The P only exists in this one term. So we need to get this by itself. The only other term on this side is this 4r cubed. So we're going to get rid of that. How do we get rid of it? We add it. This is just like solving any other equation. It's just that instead of having lots of numbers, you just have lots of letters. So we add 4r cubed to both sides. 4rq cubed. It goes away on the left, as it should. Don't be too quick to cross it out, right? You want to make sure that it actually does go away, because some of you get a little bit careless and you don't really think about it. And I'll see some of you subtracting the 4rq cubed from both sides by accident. Okay. So what are we left with here? Well, on the left, we only have the 12p q to the 5th now. Okay, so which is what we want. Then we have 8r squared q to the 4th plus 4l q squared plus 4r q cubed. Okay, where do we go from here? Well, again, we're solving for the p. We want to get the p by itself. So we need to get rid of the 12 and the q to the 5th. So we're just going to divide everything by that. So it cancels on the left, which is what we want. And let's rewrite this. So you don't always, you can sort of start, if there's something to cancel, you can start doing that here. You can cancel more than one thing at a time if you want. This is just to break it up for anybody who's having trouble with the canceling. Okay. So we have P equals, and I'm going to rewrite this whole thing, 8r squared q to the 4th plus 4l q squared plus 4r q cubed, and then this whole thing is over 12q to the 5th. Okay, so remember, p is by itself now, but we have to make sure that we can't reduce this fraction. So how you go about this is up to you. It might be helpful to just look at the coefficients first so that you never forget about those coefficients, okay? So we're looking for something that 8, 4, 4, and 12 all have in common. And they do have something in common. They all have a 4 in common. So let's reduce this. So we're taking out a 4 from the 8. Remember, you're dividing. There are 2 4s in 8. We're crossing out a 4 and we're crossing out a 4. Okay, there's only one 4 in 4. There are 3 4s in 12. So now I'm going to rewrite this again. You don't have to. You can do your next set of canceling if you want to. So we have 2r squared q to the 4th plus lq squared. So notice the 4 went away. Plus r q cubed. And then this whole thing over 3q to the 5th. Okay, so again, we're looking, does everything have something in common? And they do. They all have a q. The question is, how many q's? Well, you're going to go and you're going to look at the lowest power. This is what you can cross out. So this is saying you can take out up to 2 q's. You can't take out 3 because then how you would be taking out more q's than this one has. Okay. So if we take out 2 q's from 4, we're left with 2 of them. Here, both of them go away. Here, we're left with 1 of them. So notice I just cross out the power. I don't cross out the q as well. And this one, there were 5. We're taking out 2 of them. Now we're left with 3. Okay. So what does this turn into? P is equal to 2r squared q squared plus L, so the q squared went away over there, plus RQ over 3q to the 5th. And here's your final answer. There's nothing that everything else has in common. This is as hard as it'll get. You'll never get anything harder than that. Okay? So these are literal equations. This is a good time to take a break. So if you've watched this video and you're kind of getting tired and sleepy, take a break and come back to this video for the next section. Okay? Okay, so the very last thing about linear equations is something called the average rate of change, or the difference quotient. Now here's why this is different. It doesn't deal with a line. It actually deals with a curve. Okay, so we're going to start with something called average rate of change. They're actually the same thing. It's just average rate of change is more specific. Okay, and when I say they, I mean average rate of change and difference quotient. So here's what this is. The average rate of change takes 2 points on any curve, so it doesn't have to be a line, a curve. And it connects them with a line, and it takes the slope of that line. So the average rate of change is the slope of a line connecting two specific points. And this is going to become important because for difference quotient, they're not specific. So what do we mean here? Here's the curve. Okay, here's your curve. It would be a function, okay? And what we're going to do is we're going to take two specific points on this curve. Let's say that we take one here and we take one here. And we're going to draw a line that connects them. The average rate of change is the slope of this line. Okay, and keep in mind that it doesn't have to be these 2 points. I could have given you 2 other points. So I could have given you this point and this point instead. Okay, and then the average rate of change would have been the slope of that line. Okay, so average rate of change is giving you 2 very specific points. It's saying, okay, what is it at x equals 2 and at x equals from x equals 2 to x equals 4? What is the average rate of change there? Okay, so let's talk about how to find this. We're talking about slope, right? That's why we say rate of change. Rate of change is slope. This is what slope is. So that's why we say that it's the slope of a line connecting 2 specific points on a curve. Okay, so rate of change or slope is change in y over change in x. That's what we're using here. And if you remember, we can write that as y1 minus y2 over x1 minus x2. Well, that's what we're using to find the average rate of change. So let's just take an example, okay? Let's say that you're given f of x equals 2x squared minus 3x plus 6. And we want to find the average rate of change from x equals 2 to x equals 5. Okay, now what this means is we're drawing a curve, okay, and on this curve we're going to take whatever the point is at x equals 2, and we're going to take whatever the point is at x equals 5, and we're going to draw a line. So let's just take, I'm actually going to open up if it opens. Let's see if my computer is fast enough. Okay, so we're going to go to a website. Some of you may be familiar with this. It's called Desmos, and it's Desmos Calculator. This is great for graphing, okay? And we're going to, so you should, they have a really helpful user manual. You can just go to the question mark up here with the help, and it tells you exactly how to graph all different types of things. So the keyboard is over here. So if you want to do square or any of those, you can do that. This will become more relevant to you later, but I just want you to understand what's going on here. So let's do 2x squared minus 3x plus 6, okay? So what we want to know is I just want to make sure that. Okay, so for example, okay, what we're doing is we're going to take this point right here because that's at x equals 2. You can see this dark 2 at the bottom. We're going to figure out what the y is because that's going to give us this point. We're told we want to find the average rate of change from x equals 2, and then we have to go all the way to 5. And if we go all the way to 5, notice it's way up there. This is quadratic. This is going to be a little hard to see. We're going to have a very steep slope here. Okay. We're still going way up. Now we're going to find this point. You can see that 5 at the bottom over here. So we're going to find this y value over here. So we're going to find the two y values. Why are we doing that? Because it's y1 minus y2 over x1 minus x2. You're given the x's. You need to find the corresponding y's. Okay, and what this does is it gives you a specific point on the graph. How do we do this? We just plug it in. Okay, so we're going to find f of 2, right? We're just going to plug in 2. So 2 squared is 4, so we get 8. 2 times 4 is 8. Then we have minus 6, because 3 times 2 is 6, plus 6. Okay, 6's will cancel, and we get 8 here. So this gives us a point, actually. This gives us the point 2, 8. So 2, 8 is your x1, y1. Okay, now we need to find the corresponding y value for x equals 5. So we're going to do f of 5. So 2 times 5 squared minus 3 times 5 plus 6. 5 squared is 25, so multiply that by 2, we get 50. 3 times 5 is 15. So 50 minus 15 plus 6. Okay, 50 minus 15 is 35, plus 6 is 41. So this gives us our second point. Here's the x, here's the y. We did this with piecewise. It's just that here we don't have to figure out what function. There's only one of them. Okay, so our second point is 5, 41. And this is our x2, y2. So now we find the slope using these 2 points. So our y1 is 8. It doesn't matter which one is x1, y1 and x2, y2, as long as you're consistent. In other words, don't make this x2, y1, okay? These numbers have to match. So which one we used, it doesn't matter. As long as you're consistent, it doesn't matter which one is x1, y1 and which is x2, y2. Okay. So we get 8 is our y1. 41 is our y2. 2 is our x1. And 5 is our x2. And now we just simplify. 8 minus 41 gives us negative 33. 2 minus 5 is negative 3. And this simplifies to 11. That's our average rate of change. Okay? Specifically for x equals 2 to x equals 5. If I gave you different x values, then you would wind up with a different rate of change, right? Because think about it. On this graph, 2 to 5, it's a very steep slope, right? It goes up very, very quickly. If we go back to where we actually see the graph turn around, if I connected points over here at x equals 0 and over here at x equals 2, it would have a very different slope, okay? It wouldn't have a slope of 11. It would have a slope of, let's say, a half. Okay, or as you go over 2, you go up 4. So you would have a slope of 2. Sorry, slope of 2. No, as you go over 2, you go up 2. I'm sorry, because I forgot the scale. The slope is 1. That's the only thing that you have to realize here. The slope would be 1 here, okay? If we were going from x equals 0 to x equals 2. Whereas when we were doing x equals 2 to x equals 5, the slope was 11. So it's a very different slope depending on which x values you choose, okay? Okay, let's do one more of these and then we'll talk about the difference quotient. So let's say you're given a different f of x. X cubed minus 2x squared plus 7. Okay, let's go to our graph and just see what that looks like. And this is actually what we're going to be talking about in the next unit, exactly what graphs like this look like. This is a polynomial graph. So next week, we'll start to talk about polynomials. So you could see what this looks like, right? It's kind of like it goes up and then it goes down, okay? And then back up again. So this is what graphs that have an x cubed look like, okay? And what we'll do is we'll find, we'll look at x value from -1. We'll do from -1, and what we'll find is here's the y value actually, okay, right? So we'll have to find the y value because most of the time you're not going to be graphing it. And we'll go to 1. So we're going to take this point and connect it with a line. And what we're going to do is find the slope of that line. And I want you to note that that would be very different than if we took this point over here at the top and we took x equals 1. That slope would be much steeper. It would also be negative. Okay, so the slope changes depending on which x values you choose, because when we connect the 2 points with a line, it looks very different, right? Connecting this point and this point with a line would be a very steep line. Connecting this point with this point, just drawing a line connecting them, would give us a slightly, it's not going to be quite as steep, and it's going to have a positive slope. So let's do that. F of x, we're going to find the average rate of change from x equals -1 to x equals 1. Okay. So we're going to find the corresponding y's first. So we plug in -1 and we plug in 1. So f of -1. You can use a calculator for this, just be careful. This whole -1 is being cubed, okay? This whole -1 is being squared. So -1 cubed leaves us with a -1. -1 squared is a +1, so -2 times 1 is -2. Plus 7 And this gives us a 4. Negative 3 plus 7 is 4. Now we're going to do the same thing for f of 1. Or actually, let's just write out the point first, right? So our point is negative 1, 4. And we'll call this x1, y1. Again, it doesn't matter. You want to call it x1, y2, that's fine. X2, y2, that's fine. Okay, now we're going to find f of 1. So we have 1 cubed minus 2 times 1 squared plus 7. So we have 1 minus 2 plus 7. This gives us 6. Okay, so our second point is positive 1 comma 6. That's our x2, y2. Now we find the slope. So slope starts off with y2 minus y1. Our y2 is 6. Our y1 is 4. So we're doing 6 minus 4. Okay. Then we're going to do the same thing. Now, I realized in the last one I wrote y1 minus y2. This is the same thing as y2 minus y1 over x2 minus x1. It gives you the same answer because you wind up with just a negative over a negative. So 6 minus 4, as long as you're consistent, if you're putting this 6 first, then you have to put this 1 first. 1 minus negative 1. So this gives us 6 minus 4 over 1 plus 1. Okay, minus the negative is positive. This is 2 over 2, or 1. This is our slope. That's our average rate of change. Okay. And I'm going to put an A here because I want to show you the difference. Let's do a B. And the B is, let's do the same thing, same function, but this time we're going to find the average rate of change from x equals 0 to x equals 1. Okay, just to see the difference in the same function. So we do it through the same order. So we're going to plug in x equals 0 and x equals 1. So f of 0 is 0 cubed minus 2 times 0 squared plus 7. 0 minus 0 plus 7. And that just gives us 7. Okay, so what's our point? 0, comma 7. And this, again, we could call this x1, y1. Now we have f of 1. Now f of 1 we already calculated. We know that it's 6. Okay, it's the same function, so the y value for 1 is going to be the same. So 1 comma 6 is our x2, y2. And now we just find our slope. So you'll see, again, we can do whichever point we want first. So we could use the 6 and the 1 just like we did here. So it's going to be 6 minus 7 in the numerator because that's the change in y. And in the denominator, it's going to be 1 minus 0. This gives us negative 1 over 1, which is negative 1. So notice 1 was positive, 1 was negative. Okay, turns out that they're equally as steep, but 1 was positive, 1 was negative. Okay. Okay, so this is average rate of change. Now, if you need another break, you can get another break. So this is another good time to pause the video if you're feeling kind of tired, but we just have a little bit left, okay? The only difference between what we did here and the difference quotient is that the difference quotient generalizes this. This helps us find the average rate of change for very specific points, very specific x values. The difference quotient allows us to find the slope for any 2 points, okay, without knowing what those 2 points are. So we're drawing a line through each of these, okay, but we can choose any 2 points and the difference quotient will be able to tell us the slope for any of those 2 points without plugging in specific x values. So I'm going to draw you another picture which is similar, okay. So let's first define our difference quotient. So this is the slope of a line that connects any 2 points on a curve. This is less specific than the average rate of change, okay? So here's how this works. I'll try and make this big so that you can really see it. We're just going to take an example with one curve, okay? Again, the equation of this curve is not super important right now. It's just how we're going about finding the difference quotient. So let's just take a curve that looks like this. Okay. And let's take any 2 points on this curve. So I'm just going to choose 2 at random. Doesn't matter what they are. We're going to choose these 2 points and we're going to form a line. Okay. Okay. Here's how we do it. We call this, let me put this in a different color though. We're going to call this x. This is our first x, and we're going to call it x. And what we're going to do is instead of giving you a second point, we're going to generalize this more. And we're going to say, okay, if this is x, then the distance to our next point is h. So this has a distance of h, which means, sorry, that didn't come out so well, which means that if this is x, then this is x plus h, okay? So if this were -2 and this distance were 5, then to get this, we would do -2 plus 5. If this were 3 and this were a distance of 8, then to get this value, we would do 3 plus 8. Okay, so this number over here is x plus h. So instead of using specific numbers, we're just going to use x and we're going to use x plus h as the x values of our 2 points. Okay, so these are the x values of our 2 points on the curve. Notice we're not giving you any numbers. That's because we want this to work for any 2 points. Okay. Corresponding y values, think about how we write it. Are what happens when we plug in x, right? So in average rate of change, we said it was f of -1. So think of -1 as your x, okay? And what happens when we plug in x plus h? So we have our x values and we have our corresponding y values, right? So think about it this way. In this one, x is 1, x plus h, sorry, x is -1, and x plus h is +1, okay? And our h here was 2, right? The distance between the two x's is 2, so that's our h. Here, our x was 0, and our x plus h was 1. So what's h? H is 1, because the distance from 0 to 1 is 1. Here, our x was 2, our x plus h was 5, which means that our h was 3, because that's the distance from 2 to 5. Okay? So what does this mean? Our difference quotient is still the slope, right? So it's going to be f of x plus h. That's the first y value, right? Our second y value is f of x. Our first x value was x plus h. And our second x value was x. Okay, so our points were our x, comma, our y. This is like your x1, y1. And our x value, comma, y. And this is like our x2, y2. Okay, so these are our points. This is a t. Okay, so our y2 minus y1 over x2 minus x1. And here's the thing, the x's go away, right? The x's cancel. So we can simplify this just a little bit further. Okay, so our difference quotient, which I will abbreviate as dq, is f of x plus h minus f of x over h. Okay, this is our difference quotient. So it's change in y over the change in x. The change in x is really just the distance between the two x's, which is h. Okay? Okay, so how do we find this and what does it mean? So what we're going to do is we're going to take the function that we took before. We won't do cubic. We'll do this quadratic here. And we're just going to we're going to find the general difference quotient, okay? And then we'll use that to find the average rate of change, specifically from x equals 2 to x equals 1. So average rate of change is specific. So remember, I'm abbreviating difference quotient as dq. Okay, well, here's what we need to do. We need to find that f of x plus h, right? Because the difference quotient is f of x plus h minus f of x. So let's do that first. So f of x plus h says replace every x. Remember, you're plugging in x plus h with x plus h. So we have 2x squared, but instead of x, it's going to be 2 times x plus h squared. Then we have minus 3x. So instead, it's going to be minus 3 times x plus h plus 6. This is our f of x plus h. Okay? So Every x that we had here, we replaced it with x plus h. If it helps, put the x in parentheses. I'm circling them. Every x becomes x plus h. Okay, so now our difference quotient is f of x plus h minus f of x. Don't forget that minus f of x over h. So what does this look like for this function? Well, f of x plus h is right up here, right? Here's your f of x plus h. So 2 times x plus h squared minus 3 times x plus h plus 6. Then we have to subtract f of x. F of x is 2x squared minus 3x plus 6. And we are dividing by h. So here, this piece is the f of x plus h. If you have to, draw boxes so that you don't forget the second part. Minus, this is your f of x. Right? So we have f of x plus h minus f of x over h. Okay, from here it's just a lot and a lot of algebra. So the algebra, the plus side is that the algebra is pretty much the same all the time, okay? So I'm going to put a note at the bottom of this page. X plus h squared is x plus h times x plus h. That means we get x squared plus 2xh plus h squared. So this is just a side note. And I put this here because we're going to be using it over and over again for all different difference quotients. Okay? So let's use it here. Now it's just algebra. Okay? So take it slowly. First of all, if I say you don't have to simplify, you're done. Okay? But you should expect to simplify. So we have x plus h squared. Now we already know what that is. So we have 2 times what we see down here, which is x squared plus 2xh plus h squared. Now we can distribute this 3 as we go. So we get minus 3x minus 3h plus 6. And then we have to distribute this minus sign. Minus 2x squared plus 3x minus 6. And this whole thing is over h. So what we did here is we distributed the minus sign. We distributed this 3. And we squared the x plus h squared. Okay? Now let's get rid of this last set of parentheses. Now if you square the x plus h and you multiply by 2 simultaneously, I'm okay with that. Just be very careful. Okay? So equals 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 6 minus 2x squared plus 3x minus 6. And then this whole thing is over h. So here's something that will always happen, which is kind of cool. Okay? What will always happen is that your f of x every term up here in f of x is going to go away. We have 2x squared and negative 2x squared. They cancel each other out. We have negative 3x and plus 3x. They cancel each other out. And we have positive 6 and negative 6. They cancel each other out. So notice what we're left with. Four xh plus 2h squared minus 3h. And this is all over h. Okay, well, we just saw this when we looked at literal equations. Everything has an h in it. So we're just going to cross out an h from each thing. That h goes away. This h goes away. Now there's only one h left. And this h goes away. And now we have our difference quotient. Our difference quotient is 4x plus 2h minus 3. That's the difference quotient. This is saying if I give you an x and I give you an h, you can find the slope of any single line connecting any 2 points on that function. Okay? So, for example, we'll go back to the average rate of change. The average rate of change that we used for this one for this function was from x equals 2 to x equals 5. So in that case, x is equal to 2 because we take the first x value, and h is equal to 3 because that's the distance to the next one. So if x equals 2 and h equals 3, now we can find the average rate of change. So remember, average rate of change is you're given something specific. 4 times 2 plus 2 times 3 minus 3. So this is 8 plus 6 minus 3, which is equal to 11. And if you remember, if we go back again to look at that, look at what the slope is, 11. The difference quotient becomes really useful when you have something like this, where you're given you want to find the average rate of change for two different x values twice, okay? Because then instead of doing this work every time, all you have to do is plug in x equals negative 1, h equals 2 into a very simple expression. Then you would plug in x equals 0 and h equals 1 into that simple expression, and you would get 1 and negative 1. Now, both of those are for an x cubed. For an x cubed, for something like this, okay, when you're actually doing these calculations, an x cubed, I will not make you simplify. It would be enough just to write, your x plus h cubed, just to stop at this step here, okay? For an x plus h squared, okay, for an f of x where you have an x squared, you should be comfortable simplifying. So we'll do another example, okay? Let's just do one more thing here. Let's say, for example, if x equals 0 and h equals 4, the average rate of change is 4 times 0 plus 2 times 4 minus 3, which is 0 plus 8 minus 3. So the slope of the line connecting the points at x equals 0 and x equals 4, because the h is equal to 4, would give us a slope of 5. Okay, so this is just an example as to how we could use it. We could do it for any 2 points. We just plug it right back in there. Okay. Okay, let's do one more difference quotient for a different function. We won't do the average rate of change through there, but you should know that this is the same thing as plugging in 0, getting a y value, plugging in 4, getting a y value, and I say 4 because 0 plus 4 is 4. Okay, here it would be plugging in 2 and plugging in 5 because 2 plus 3 is 5. And I'm finding the slope based on that, just like we did with average rate of change. It's the same exact process. Okay, so difference quotient allows us to do it with all different x values. Okay, we'll do another one just so that you get accustomed to the algebra. Okay. Find the difference quotient for f of x is equal to, let's make it 3x squared plus x minus 4. Okay. So now we're not going to do average rate of change. We're just going to go through the algebra and do the difference quotient. So remember, the first thing that you have to do is find f of x plus h. You should, by the way, stop, pause the video, do it on your own, and then restart it and see if you're getting it correct, okay? Particularly when we do the algebra, but even before this, see if you can do the difference quotient. So remember, what this means is that every x is being replaced with an x plus h. So you just go through this function. We see 3. Instead of x, it becomes x plus h, and that was squared. Then we have plus x plus h instead of x minus 4. Okay. So the difference quotient is f of x plus h minus f of x over h. You don't have to write this every time, but it can be helpful to remind you because the most typical mistake is that people forget this minus f of x, okay? And I'll even go back here and I'll make a note. You are only left with terms with h's. All of them have h's. Okay, so notice the 2x squared didn't have an h, it canceled. 3x didn't have an h, it canceled. The negative 6 didn't have an h, it canceled. All of your remaining terms have an h, so this will always be your last step to cross out an h. Okay, let's go back to what we were doing. So now we're replacing f of x plus h exactly with what we have up here. 3 times x plus h squared plus x plus h minus 4. That's your f of x plus h minus f of x. 3x squared plus x minus 4. And then that whole thing is over h. Okay, so this is your f of x plus h. Oops. And this is your f of x. Okay, we're going to do two things at once. We can distribute the negative, and we can actually, we're squaring the x plus h squared, right? Okay, so this is equal to 3. And then from the previous page, we know that x plus h squared is x squared plus 2xh plus h squared. Then we have plus x plus h. So we could take out the parentheses there because there's nothing to distribute. Minus 4. And then we distribute the negative. Minus 3x squared minus x plus 4. And this whole thing over h. So notice it's just a bunch of algebra, okay? That's all. Just get accustomed to the algebra. So what did we do here? We distributed this minus. And normally we would distribute something in front of this x plus h, but there is nothing in front of there. So we just pulled out those parentheses and we squared the x plus h, okay? Okay, so now our next step can be to distribute this 3. So we get 3x squared plus 6xh plus 3h squared plus x plus h minus 4 minus 3x squared minus x plus 4. Be careful, don't get lazy in doing this. Write it out. This whole thing over h. So now we're just canceling out like terms, right? So 3x squared, notice it doesn't have an h. It cancels. X doesn't have an h. It cancels. Negative 4 doesn't have an h. It cancels. If it does not cancel, you did something wrong in your algebra, okay? And then at our next step, we get 6xh plus 3h squared plus h over h. Every term has an h, so we could cancel out an h. That will always happen. This will always be your last step. So that h goes away, this h goes away, one of those go away, and then this h goes away. And this one, be careful, it goes away, but it's replaced with a 1. Okay? That's because h divided by h is 1. So what's our final difference quotient here? 6x plus 3h plus 1. If x equals 2, then our difference quotient is 6 times 2 plus 3h plus 1, or 13 plus 3h. Sometimes you'll get this where it says calculate the difference quotient for x equals a certain number. So if x were equal to 10, then your difference quotient is 6 times 10 plus 3h plus 1, or 61 plus 3h. Okay, so this is still a difference quotient. It's just giving you one piece of information. You can then find another piece. You can do the h. But right now, I'm not giving you the h. Okay, so keep in mind here what we did. From here to here, we squared x plus h and distribute the negative. Okay. From here to here, we distribute the 3. Okay, which means that we got rid of the remaining parentheses. From here to here, we combined like terms, which means canceling. It's always going to be canceling. And from here to here, we canceled an h. It's the same thing every time. Let's do one last one and then we're done. So if you've got this down, then you can just stop here. But just for anybody who wants a little bit of extra practice. Let's find the difference quotient. For f of x is equal to, let's say, 4x squared plus 2x plus 1. Okay? Pause it, do it on your own. So, what's the first thing that we do? Always find f of x plus h. So we have a 4. We see an x. It gets replaced by x plus h squared plus 2. Then we have an x plus h and then plus 1. So every time that we saw an x, it's replaced with an x plus h. This was an x squared, now it's an x plus h squared. This was a 2x, now it's a 2x plus h. Okay? Now we can find the difference quotient. So remember, this is just algebra. Bunch and a bunch of algebra. So I'm going to write this again so that it's always in front of you. And so that you never forget to do that minus f of x. Most common mistake. You're going to know it's a mistake, by the way, because you'll get terms without h's in the end. So f of x plus h is 4 times x plus h squared plus 2 times x plus h plus 1. Now we have to subtract the f of x. So minus, we put it in parentheses so that we don't forget to distribute. 4x squared plus 2x plus 1 over h. Okay, now we get rid of a bunch of stuff, right? So you can do more than I do in a given step. Some of you would combine steps, but again, be careful. If you combine too many steps, then I'm not going to know where you went wrong if you went wrong, okay? So some of you may distribute the 4 as you square. That's okay, but be careful. So we square the x plus h. We can distribute this 2 as well, plus 1, and then we distribute the negative. Make sure that you actually do distribute the negative. And again, when we do the algebra, it's always going to be easy to know where we made a mistake. We're going to distribute the 4, so we get 4x squared plus 8xh plus 4h squared. Then plus 2x plus 2h plus 1 minus 4x squared minus 2x minus 1 over this whole thing over h, right? And then we said the next thing to do would be to combine our like terms. We have a negative 4x squared and a positive 4x squared. Notice it's a term without an h. It cancels. The 8xh has an h. It's not going to cancel. Same thing with the 4h squared. But 2x will cancel. If it doesn't cancel, you made a mistake in your algebra. The 2h has an h. We leave it. The 1 cancels. And what are we left with? We're left with all the terms with h's. 8xh plus 4h squared plus 2h over h. And now we know we can cancel an h because it's in every single term. Notice you never have a denominator, right? And then finally, this is equal to 8x plus 4h plus 2. Okay, so you'll always have a term with an x and an h. You'll see terms like this. It'll always look similar to this. And just before I log off, one quick thing, which is actually kind of cool. I want to go back to, so this is one of the most important things that we cover in this class. And the reason why is that this is the fundamental of calculus. Okay, so calculus, this is average rate of change. Calculus, study of calculus is instantaneous rate of change. So what do we mean by instantaneous rate of change? The difference is that we're saying that the 2 points, instead of being this far apart, in calculus, we're saying they're right next to each other. Our h is infinitesimally small. And it's saying, what's the slope of that line? As h gets smaller and smaller and smaller, what is the slope of the line connecting the 2 points? So we see that this is our slope. If I moved to the point over here and I connected this line, what would happen? If I moved the point over here, what would happen to that line, the slope of that line? And if I move the point right here next to the first point, what would the slope of that line be? That's what calculus it is. It's asking what is the slope when they're right next to each other, okay? So this is, and for anybody who's ever heard anything from calculus before, that's derivative, okay? Derivative is exactly this, but it's saying, okay, but what happens when h gets really, really tiny? Okay, so this is the big intro to calculus. And that is it for today.